Here we're going to talk about the fact that the Nash equilibrium is Pareto inefficient. We're going to try to think about how we actually diagnose the fact that it's Pareto inefficient. So, to start, what we've done is we've taken the figure that we saw previously of the best response function with the isocost curve, and you can see that here. We've got the best response function as the purple line, and we've got the isocost curve as the blue line. But then you can see we've also added a couple of other lines. We've added back in the agent's isovalue curves. So you can see here we have an isovalue curve for the agent, V4. We've also added in a shaded area, which is the Pareto improving lens. A couple other things to notice about the figure. We're showing in the figure which directions are better for the principal and agent respectively. So for example, you can see that here we have the direction that's better for the agent, right? The agent is doing better as they move further along the price axis. That means they're basically getting a higher price for the level of quality that they provide. For the principal, on the other hand, they do better as they get steeper isocost curves. So the better for the principal is basically going up towards the corner. Okay, so thinking about that, we're trying to think through whether the Nash equilibrium is Pareto inefficient and what alternatives there might be. We see that the Nash equilibrium allocation, or we're just going to say for the moment the Nash equilibrium allocation, PNQN, is not Pareto efficient. And we have to ask ourselves, how can we see that PNQN is not Pareto efficient? So I'm going to try to get you to answer that question for yourselves. Now, to answer that question, remember the definition of Pareto efficiency. An allocation is Pareto efficient if there exists no alternative allocation that is Pareto superior to it. So what that means is we have to try to find an alternative allocation that is Pareto superior. If no such allocation exists, then an allocation is Pareto efficient. Alternatively, if an alternative allocation is Pareto superior to the one that we're thinking about, then the one we're thinking about is not Pareto efficient. Therefore, the question becomes, is there an allocation that is Pareto superior to the Nash equilibrium? So try to find something like that for yourself in the figure, and then I'll explain what we mean. Okay, so we're going to assume that you've paused and tried to find a point that is Pareto superior to the Nash equilibrium. And we can see that in this figure, that point is point F. So remember, all the points in the Pareto improving lens are in fact Pareto superior to the Nash equilibrium. That's the definition of what we have to get, because to be a Pareto improvement, they must be Pareto superior. But the one we highlight here is point F. And what we can see here is that point F is on a higher isovalue curve for the agent. So that dashed isovalue curve for the agent, it's not the one at the Nash equilibrium, but it's a hypothetical alternative. That is Pareto superior because the agent is doing better, V5 is higher than V4. And what can we also see for the principal? Although we have not drawn the principal's isocost ray, at point F, the principal's isocost ray going through that point would be steeper. So both parties would be better off at point F than at point N. F is Pareto superior to point N. Okay, so if there is an alternative Pareto superior point, what do we know? The Nash is not Pareto efficient because there exists a Pareto superior alternative. Okay, so the question is, how do we know that this Pareto improving lens must exist? All right, that's a question that we're going to have to ask ourselves. How do we know that point F, which lies in the Pareto improving lens, exists as a point in that lens? Well, let's go through the following reasoning. We know that Patricia is implementing the MRS equals MRT rule. So MRS equals MRT at the Nash equilibrium. She's choosing the point where the marginal rate of substitution, which is the negative of the slope of her isocost curve, is equal to the slope of the best response function, the MRT, and the MRT is the negative of the slope of the best response. So MRS equals MRT, the negative of those two slopes are equal, therefore the slopes are equal. Okay, so a Pareto efficient outcome, on the other hand, requires that the principal's marginal rate of substitution, MRSP, equals the agent's marginal rate of substitution, MRSA. Okay, and so the agent's marginal rate of substitution, what's that going to come from? That's going to come from their isovalue curves, the isovalue curves. So we've got the agent's MRS coming from their isovalue curves, and the principal's MRS coming from her isocost ray. Okay, so we know something about both of those. We know what their slopes are looking like. So let's think to ourselves, can we get a point, or is it the case that at the Nash equilibrium, the two marginal rates of substitution are equal? Is that happening at the Nash? Well, let's try to answer that question. MRSA equals MRSP at a tangency of the agent's isovalue curves to the principal's isocost curves. All right, so the thing is that her isocost curves, or isocost rays, they have a positive slope. Now, what do we know about the agent's isovalue curves at points along the best response function? Well, they're vertical at points along the best response function. Remember, we said that they're going to be tangent to any price in order to give us the point on the best response function. Therefore, they themselves are vertical. So what that means is that we've got a vertical isovalue curve and a positively sloped isocost ray. Their slopes are definitely not equal at that point. So the points that just came up, those are summarizing what I just said. Armand's isovalue curves are, by construction of the best response function, vertical at all points on the best response. So we cannot equate the principal's marginal rate of substitution from her isocost rays to the marginal rate of substitution from the isovalue curves, if we're thinking purely of points along the best response function. But what we do see is that the Pareto improving lens exists because the Pareto improving lens shows us all alternative points to the Nash equilibrium given by the isovalue curve. So we've got, what do we have there? We've got the range between the Nash equilibrium isovalue curve V4 and the principal's isocost ray C2. The points in between those are all points where we would be either on a lower isocost ray, or a steeper isocost ray but lower costs for the principal, and a higher isovalue curve for the agent. Are those necessarily Pareto efficient? No. In order to find Pareto efficient points, we'd have to find points at which the isocost ray was tangent to a comparison isovalue curve. Okay, so the explanation for this is that we're going to be thinking about the incomplete contract, right? And so to think about the incomplete contract, we have to think, why is this Nash equilibrium inefficient? It's inefficient because of the incomplete contract. So it's because the agent, in deciding the level of quality to provide to the principal, is not taking account of the effect of their choice on the buyer, on the principal. Now that is a negative external effect, right? So the agent, from their choice, they have a negative external effect on the principal. Now what you should remember here is that there's a tie between negative externalities or negative external effects and contractual incompleteness. So the agent doesn't cater for the effects of their choice of quality on the principal because that quality cannot be specified in a contract. There is contractual incompleteness between the two of them, and so we have this external effect as a result. What you're probably going to remember too is that when you had external effects, what happened? Well, we ended up at inefficient outcomes. If you looked at examples like pollution or noise pollution or similar ones previously, what you would have seen there is unless people can be basically forced to pay for the consequences of their external effects, we're not going to have a socially efficient outcome, which is what we'd be expecting if we were able to get a Pareto efficient outcome. Now, looking ahead, what comes next? we are going to compare what happens in the Pareto inefficient Nash equilibrium with the complete contract case, which is Pareto efficient. We're going to see in the incomplete contracting case, the agent receives the enforcement rent that we spoke about previously.